we have given that a smooth block is released at rest on a 45-degree incline and then slides a distance d. The time taken to slide is n times as much to slide on a rough incline than on a smooth incline. The coefficient of friction is so on an incline of inclination 45 degree, a block that is at rest, initial speed u is 0 and it slides a distance d. And if this surface is smooth, then time taken, suppose t1, and if it is rough, then time taken, suppose t2, then according to the question, t2 is equal to n times t1. Then we have to find coefficient of friction mu. So on a smooth panel, initial speed u is 0 and it is smooth, so friction will be 0 and mg will act downward if the mass is m and this angle is 45 degree, so this angle will be 45 degree and force in this direction will be mg cos 45 degree and force in this direction will be mg sin 45 degree. So net force on block F, it is equal to mg sin 45 degree and sin 45 degree is 1 by root 2, so it will be mg by root 2 and F is equal to mass times acceleration and F is mg by root 2, that is m times a and m will get cancelled, so a is equal to g by root 2. And s is equal to ut plus half a t square and u is 0, so ut will be 0 and distance is d. It moves a distance d, that is equal to half times a is g by root 2 times time is t1 square. So D is equal to G by 2 root 2 times T1 square, and T1 square will be 2 root 2 D by G. And on a rough incline, this angle is 45 degree, and mg will act downward if mass of is m, and this angle will be 45 degree. So force in this direction will be mg cos 45 degree, and in this direction will be mg sin 45 degree. And friction force F, it is equal to mu times N, and it will be equal to mu times, and N, it will be equal to mg cos 45 degree. N will be mg cos 45 degree. So net force on block F, it will be equal to mg sin 45 degree minus mu mg cos 45 degree. It will be mg sin 45 degree minus mu mg cos 45 degree, and F is equal to mass times acceleration, that is equal to mg, and sin 45 degree is 1 by root 2 minus mu mg cos 45 degree is 1 by root 2, and m will get cancelled. So A is equal to g by root 2 minus mu g by root 2, and S is equal to ut plus half a t square, and u is 0, so ut will be 0. So S will be equal to half times, and A is g by root 2 minus mu g by root 2, and time is t2 square. And S is equal to 1 by 2, and here we can take g by root 2 common, and it is 1 minus mu times t2 square. So t2 square will be equal to 2 root 2, and S is equal to d by g times 1 minus mu, and t2 is equal to n times t1. So t2 will be a square root of 2 root 2 d by g times 1 minus mu, that is equal to n times and T1 square is 2 root 2 d by g. So T1 will be a square root of 2 root 2 d by g, and a square root of 2 root 2 d will get cancelled, and a square root of g will get cancelled. So a square root of 1 by 1 minus mu, it is equal to n times a square root of 1, and a square root of 1 by 1 minus mu, it is equal to n, and if we square both sides, then a square and a square root will get cancelled. So 1 by 1 minus mu, it is equal to n square, and 1 by n square will be equal to 1 minus mu. So mu will be equal to 1 minus 1 by n square. Mu is 1 minus 1 by n square.